Hi, hello everybody. So this is the video dealing with section 12, solving polynomial equations by factoring. And although there are different techniques to solve these polynomials, we're going to employ the basic techniques of factoring, which you can see here. Now, just as a review, uh, GCF, factoring the greatest common factor, grouping, factoring a trinomial, difference of squares. And even though this is one of the techniques, sum difference of cubes, I don't think we're gonna see this in solving the problems associated with section 12. Okay, so it's primarily uh, GCF, grouping, the trinomial, and difference of squares, and those that we have to know. Now, so when we see a polynomial, which is going to be an expression involving multiple terms with x to either the first, second, third, fourth power, we are going to try to factor the polynomial using one of these techniques that we've covered before. These four: GCF, grouping, trinomial, difference of squares. Once we do that, after we have done that, after the polynomial is fully factored, okay, after the polynomial is fully factored, it's going to be in product form. We're going to have maybe the first term times the second term times the third term times the fourth term and so on and so forth. And that's going to be equal to 0. Okay. At that point, we're going to apply this property that we call the zero product property. The zero product property says the following. If I have two things, okay, multiplying each other and the product is 0, now that means that one of them has to be 0, right? So if I multiply five times the box and the result is 0, then the box has to be 0. If I have two boxes and I don't know what's in those boxes, but I know that the product is 0, then either the first box is 0 or the second box is 0. This is what the zero property rule says. Okay, it's very basic, and we can use it in here to get our answer. So let's take a look at some basic, very basic examples. All right. I am going to begin with this case because I think it's easier. Okay. So so we always want to begin with a 0 here, right? So for example, in this case, I need to properly set the polynomial to start. So I would do minus 28x on both sides. And I would get this. Okay. This is my starting point. So now all of the four examples are in proper format. I'm going to do 12.4 first. So the techniques that we know, GCF, grouping, trinomial, difference of squares. Now we have to identify which one it is. So always check GCF first. So in this case, I can factor an x. Okay, and I would get 5x here minus 7 equals 0. This is as much as I can factor in this particular polynomial. There's nothing I can factor here. There's nothing I can factor here. So at this time, I apply the zero product rule, which says either x is 0, this factor, or 5x minus 7 is 0. Well, the x is 0 is obvious. It's already solved. In this case, I need to solve this equation. So I'm going to add 7 to both sides. And I'm going to divide everything by 5. And that's it. I'm done. So this problem has two solutions. X is 0. X is 7 over 5. Now, do not write it this way. Okay? This is very wrong. This is not a point. Both values are x. So just leave them like this. Okay? All right. That's the first example. I'm going to erase this because I'm going to need this space. And I'm going to do the second problem, 12(7). Now, I already told you that this needs to be put in proper form, which means equals to 0. So here it is. Now, I look at this polynomial and I see which technique I have to employ. You always try GCF first. So in this case, I can see a GCF, which is 7x. And I will get x squared minus 4. Now, there's nothing I can factor anymore on 7x, but can I factor x squared minus 4? And the answer is yes. And it's difference of squares. So I factor that. Now, just keep in mind that you have to know how to do the factoring techniques in order to solve these polynomials. So we're not reviewing the techniques here right now because we've covered them before. But in case you need to refresh your memory about them, go back and watch my videos and reacquaint yourself with the proper techniques of, for example, GCF, grouping, trinomials, or difference of squares. Okay, in this case, x plus 2, x minus 2. At this point, the polynomial is fully factored. Now, by the zero product rule, either 7x is 0, x plus 2 is 0, or x minus 2 is 0, and you solve each one. So in the first case, I just divide by 7. In the second case, I just subtract 2 from both sides. And in the third case, I just add 2 to both sides. Okay? And here are my 3 possible values, and you just stop right there. So these problems are very, very fast also, provided that you know how to factor using the techniques that we've covered. All right? Now let's do 12(8). And I'm going to erase this again because I'm going to need that space. So I look at this and I see that there's a 0 there. So this is a good starting point. And I look at my polynomial on the left and see which technique it is I have to use. Well, there's no GCF here. And it looks like it is grouping. Now remember, grouping appears in groups of 4. That doesn't mean that all polynomials with 4 terms are grouping or is grouping, but in this case it is. So I am going to group the first 2 and the second 2. So out of the first pair, I'm going to factor x squared. I'm going to get x minus 1. And minus here, remember, for grouping, whatever the sign is, it's factor there. And I'm going to factor a 9. And here's my x minus 1 again. I can see now that x minus 1 is still a common factor, so I'm going to factor it out. And in the second pair of parentheses, I get the x squared minus 9. The x minus 1 is fully factored, but x squared minus 9 is difference of squares. So I factor that out. Okay, x plus minus 3, 3. And now by the zero product rule, now we can only use the zero product rule when you have a product of all factors. All right, that's why I'm able to do it here and not able to do it there. So x minus 1 is 0. X plus 3 is 0, or x minus 3 is 0. Add 1 to both sides. X is 1. Subtract 3 on both sides. X is negative 3. Add 3 to both sides. X is 3. Okay. So very straightforward, very fast, provided that you know the factoring techniques. All right. And last, we're going to do this one. Erase this again. Erase all of that. The polynomial is already equal to 0, so this is a proper starting point. And there's no GCF. This is definitely no grouping. It's not difference of squares, and it looks like a trinomial because I have 3 terms. Now, the trinomial, we're going to use the AC method, right? The product has to be A times C, which is 4 times negative 3, and the sum has to be B, which is negative 4. So I need to find two numbers whose product is negative 12, so I can try them all. 2 and 6, 4 and 3, ignore the minus, and then look at these 3 pairs and see which possible pair can give me a sum of negative 4. Now, the only possible is this, because these two either are too far apart or too close together. So I take a look at 2 and 6 and see which one can give me a product of negative 12 and a sum of negative 4. So it's definitely 2 and 6, but I have to make 6 negative. Because if I multiply them now, 2 times negative 6, I get the negative 12. And if I add them, I will get the negative 4. So once you found your pair, okay, you are going to rewrite the middle term, this term, with the pair. Right? The positive 2x minus 6x is still negative 4x. So I haven't changed the equation. But I've allowed it so that I can use grouping as factoring right here. So I'm going to factor 2x out of the first pair. I got 2x plus 1. The minus goes here, and I factor 3, which is 2x plus 1. I can see that 2x plus 1 is a common factor, so I factor that out again. And in the second pair of parentheses, I am going to put 2x minus 3. Now, because I have a product, I apply the zero product rule, which says either the first factor is 0 or the second factor is 0. Solve each one separately, minus 1 on both sides, and divide everything by 2. Plus 3 on both sides, and divide everything by 2. So my two answers are here. Now, I am not going to check them for you. You know how to check. In all of these cases, all 4 cases, if you want, you can replace the variable with the values you found and confirm that they're 0. Okay? I'm not going to do it here for the purposes of keeping the video short. But this is how you solve these polynomial equations by factoring. Now, in this section, in addition to knowing how to do this, you may get a application problem, okay, or application type problem. Okay, so I've collected 2 from the workbook because I think those are very good, and we can solve them. Now, just keep in mind that if you have something like this on the exam, you actually have to solve the problem algebraically. Okay, what does that mean? It means that you cannot try to figure out the answer by back working or back solving this thing. So if you just write some stuff on the pages and then write 3 and 4, I'm going to put a question mark and I'll say, did you solve it? You have to solve the problem algebraically, right? So not don't try to just find the answer numerically. That doesn't count. So in all of these application problems, what we're going to have to do is we're going to read the word problem and we're going to have to introduce a variable or two variables, depending on the situation. We're going to have to translate the problem from English into a mathematical equation, and then we'll solve the mathematical equation. Okay? This is always the procedure. All right, so let's take a look. So let's see. So if 12 is subtracted from 5 times a number, so we begin right here. I don't know what a number is. So we introduced a variable. So 5 times a number is 5x. If 12 is subtracted from this, now be very careful. It's not 12 minus. It's subtracted from. All right? So this is, here's my 5x, 12 times subtracted from. Okay? The result is, how do we translate is? 6 less than the square of a number. Now, the square of a number, I know, x squared. Square of a number. 6 less than the square of a number. 6 less than is it 6 minus that, or is it x squared minus 6? 6 less than the square of a number. You got to be careful with those things, okay? Not 6 minus x squared minus 6. All right, so now, as you can see, the verbal problem was converted into a mathematical problem, and we can solve this one. Okay, so because I have a quadratic equation and it's a polynomial, I know how to solve polynomial by factoring. This is the topic of this section. I'm going to make it equal to 0. So minus 5x on both sides and plus 12 on both sides. Because now I'm going to get a 0 here. I get the x squared. I get the negative 5x. And I get the 12 minus 6, which is 6. So now this is an equation that we already recognize. It's just a mathematical problem. And we can solve by factoring. What kind of factoring is this? Well, it's just a trinomial, AC method. Product is A times C, sum is B. Now here is your A, here is your B, here's your C. So the product is 6, the sum is negative 5. Now either is 1 and 6 or 2 and 3. I have to find out which. Okay? So, can it be this one? Well, this one is out because even though I can multiply 1 by 6 to get 6, I cannot add them and get negative 5. It's just not possible. But this one works perfectly fine. All right? Well, Professor, how do you get negative 5 as a sum? Well, you do that by having both of these numbers negative. Now, if they are negative, when I add them, I get the negative 5. And if I multiply them, I get the positive 6. So this is perfectly fine. So I am going to rewrite the middle term, minus 2x, minus 3x. So here's my negative 5. I haven't changed anything, plus 6. And I am going to now factor by grouping. I factor x out of the first term, x minus 2 minus, I factored 3 out of the second pair, and I get x minus 2 here. All right? X minus 2 is a common factor. In the second parenthesis, I'm going to write x minus 3. By the zero product rule, either x minus 2 is 0 or x minus 3 is 0. I add 2 to both sides. I get x equals 2. And I can add 3 to both sides. And I'll get x equals 3. So here are my two solutions. Two possible numbers. Okay? Now, you could have just read this thing and guessed 2 and 3, but that wouldn't work, right? Because you have to solve. You have to solve them mathematically, algebraically, all right? So keep in mind that this needs to be done for credit to be assigned. So that's the first application I want everybody to know. The second application, it's very similar, but it's a little bit maybe more geometric, right? Let's take a look. Again, there's a verbal problem that needs to be converted to a mathematical problem. So they're talking about the height of a triangle. So let's draw a triangle. I'm not quite sure which triangle it is, but we can draw something. So the height of a triangle is 3 yards less than twice the base. So here's the base. Here's the height, right? So the height of a triangle, the height is 3 yards less than twice the base. Now, 3 yards less, twice the base. Don't write it that way. 3 less than twice the base. Okay? So they're giving us this kind of formula right here. That's the first paragraph or the first sentence. Now, the area of the triangle is 27 square yards. All right, I guess I didn't need the picture. All right, so I'm going to erase this picture. I thought I needed it. I don't need it. But the problem is I have one, two, three variables, but only two equations. So I cannot solve that. But then I have to remember what is the area of a triangle. Now, you don't really need to remember that on the exam, but the area of a triangle is base times height divided by 2. So I am going to replace this with base times height divided by 2. So now look what I have to work with. H equals 2b minus 3. And I have that 27 equals bh over 2. Now I'm going to adjust this equation here. I'm going to multiply both sides by 2. I'm going to write it over here to get rid of the denominator. They cancel here. I get 54 equals BH. So instead of using this 27, I'm going to use 54 equals BH. Now, can I solve this? Well, I should be able to because, look, I have one, two variables. This is the same h, and I have two equations. Look what I can do. I can get this and replace it right there. Look, 54 equals B. Instead of writing H, you're going to write 2B minus 3. Now you can solve this equation. I'm going to distribute the b. 2b squared minus 3b, and it looks like a quadratic. So now I'm going to do minus 54 on both sides. I get 0 here. I got 2b squared minus 3b minus 54. Okay, I'm going to have to erase this because I'm going to write it over here because I might need it later. 2b minus 3. This is the system I need to solve. 54 equals pH. And I'm going to erase the rest because I'm going to need the space. This is a quadratic I can solve. And I'm going to solve it by the AC method again. So product A times C, which is 2 times negative 54, which is what? Negative 108, which is like a big number, but maybe we can do it. And this is B, which is negative 3. All right. So now I have to find the pair that works. All right, so this could take a while, right? I have to find 1 and 108. That's the product. How about 2 and 54? Yeah, that I know that works too. Can I have a 3? All right. So now we're gonna probably need to use a calculator here if you cannot do this in your head. So let's see if 108 is divisible by 3. Probably not. Yes, it is. 3 and 36. And that doesn't work. How about 4? Is 108 divisible by 4? Yes, it is. 4 and 27. How about 5? 5 doesn't work. How about 6? 6 probably doesn't work, but we can check. 18. If you don't know what the answer is immediately, this is what you have to do. You have to start dividing. How about 7? 7 might not work, but we can try. 108 divided by 7. No, that doesn't work. How about 8? 108 divided by 8. That doesn't work. 9 probably doesn't work either, but we can try. Oops. 108 divided by 9. 12. 108, 12 by 9, right? So it was 9 and 12. Now look, 108 doesn't divide 10, doesn't divide 11, it divides 12. So now I'm back. When I get to 12, I get to 12 and 9. None of these work for this sum. These are too far apart. But this does work. So you are going to write again the middle term using the 9 and 12, but I'll keep in mind that the sum has to be negative. So 12 is negative, right? 9 plus negative 12 is negative 3, and 9 times negative 12 is negative 108. So b squared, 2b squared plus 9b minus 12b minus 54 equals 0. Professor, could I write minus 12b and plus 9b? Yes, you can. It's going to work just the same. But I'm going to show you that doing it this way also works. Okay. Even though you may not like it, but it's fine. If you want to write 2b squared minus 12b, you can. Now factor by grouping, and we get b, 2b plus 9, minus, and I have to factor something here, right? What is that? Is that a 6? 2b plus 9. 2b plus 9 is a common factor. Factor that out. In the second parentheses, I get b minus 6. And now by the zero product rule, by zero product rule, I get either 2b plus 9 is 0 or b minus 6 is 0. Minus 9 on both sides. Divide everything by 2. Now, there's something very important here. This is one answer, and the second one is just plus 6 on both sides. Now, this is, so here's the question. Find the base and the height of the triangle. Now, notice that your equation here is in terms of b, the base. On the exam, you have to find these two answers. But take a look at this guy. Can this be the base? Negative 9 over 2. The answer is no. Why? Because it's negative. So there is only one possibility for the base. So you only consider the base. All I have to do now is find the height. What do? I go back here. Okay, I'm going to have to erase this for space. This is a very long problem, I know, but it's a possibility on your exam. So height equals 2 base minus 3. Height equals 2 times 6 minus 3. Minus 3, now minus 9. Height is 12 minus 3, which is 9. So you found the base and you found the height. All right. So in this section, you're going to have to solve these polynomials by factoring, and you may have to solve these types of application problems. The first one was very simple and short. The second one was a little bit more involved, but they're both possible types on the exam. Okay? So in solving these problems, the application problems, it likely you're only gonna get a quadratic, but you have to solve the problem. You cannot just guess the answer, which sometimes you can. I mean, look at these numbers; they're not too difficult. Maybe somebody could guess, but you actually have to solve them algebraically.